Hello everyone, today we're going to go through experimental probability. Let's say I have a dice right here and I decided to roll it. And I did that again and again and again until I've got a bunch of outcomes. Now there are a total of 12 trials. I can have a look at all these values and put it into a table and record how often each of these numbers occurred, or in other words, its frequency. So its frequency is how often it occurs. So for example, I look at number 1 and I have 1, 2, 3, 3 ones. And I look at number 2, I have 1, 2, 2 twos. Number 3, I have 2 threes. Number 4, there's 2, 5, there's 2, and there's 1, number 6. Let me neaten that up. And when you look at this, you can add them all up and realize that it's equal to 12, the number of trials. So there are 12 dice there, or 12 rolls. So we have a total of 12 when we add up the frequency, because that's how many of each occurred. The relative frequency is talking about when we compare this to the total. So if I look at number 1, we can see that 1 occurred many more times than 6. So we can say that relative 6 has a smaller relative frequency than a 1. Or in other words, 6 will happen less often than 1. So how do we write this? So we write this 1, we put it over 12. So the relative frequency is worked out by getting the frequency of the outcome, so the value at the top, and dividing it by the total number of trials, in our case 12. And make sure that you always simplify where possible. And knowing this, we can also answer different questions. For example, how many trials were there? So we had a total of 12. If I didn't draw this picture, you can get the total by adding all these numbers. What is the relative frequency of number 3? So we go to 3 and we look for the relative frequency. And our answer is 1/6. How many 5s were rolled? So I go to number 5 and I look for the frequency, how often something occurred. And I write the answer. So you'll often see in the math questions this table over here, not so much the picture. When we don't know what the probability of an object is, let's say we have a biased dice and it's heavy on one side, then we can conduct some experiments to find out the experimental probability. And once we conduct the experiment, let's say we roll the dice many, many times. In this case, we've rolled it 48 times. Then we can figure out their relative frequency. So in this case, we can count them. 1, 2, 3, 4, 5, 6, 7, 8. We can count number 2. Where's number 2? 1, 2, 3, 4, 5, 6, 7, 8. There's a lot. And we can count how many times each of the numbers occur and write down the frequency. After that, we can put that over the total number of trials, which was 48, and simplify to get the relative frequency. So that is how often the chances of 1 coming out compared to everything else. So the best way to predict probability is by using its relative frequency. So the experimental probability is actually exactly the same as relative frequency. So let's have a look at how the questions are worded. Again, we can answer their questions. How many trials were there? So we look at the total number of frequency added together. So we add all of these together and we get 48. What is the experimental probability of number 3? That is exactly asking the relative frequency. So that is 1/3. How many 5s were rolled? That's asking for the frequency of number 5. That is 5. Okay, that's it, you guys. So make sure that whenever the question asks for relative frequency or experimental probability, you know that it's asking for the frequency over the number of trials. Bye.